A bridge 24 meters long and weighing 500,000 newtons is supported by two pillars located at each end. If a 220,000 Newton car is parked 6 meters from one end of the bridge, how much force does each pillar exert? So first I did a free diagram. We have four forces acting on this diagram. We have force 1, force 2, and then force of the car and the force of gravity. The whole thing is 24 meters long. And first I'll start by deciding what they give me, and that is 5 FC equals 220,000 newtons. Force G equals 500 newtons. And we're looking for F1 and F2. First, we start by picking the point on here that we want to use. And the total torque is equal to 0. And that's why we picked this point, because if the total torque is 0, we can pick either of these points and they will be 0 at that point. And now we're going to find the torque or the force of F1, which is torque equals force times distance times sine, sine, theta. So it actually breaks down to negative TC, which is torque of the car, which is negative because the force is going down, and plus negative torque gravity, which is actually pulling down too, but plus torque 2, which is actually pulling up to make it positive. So these are going in counterclockwise position, and this is going in clockwise position. That's why they're negative and this is positive. And every one of these are going to be a right angle. If you look right here, there's a right angle, and if you go with this dotted line across, each one of these would have a right angle on each one. So sine of 90 will be 1, because sine of 90 equals 1. So we start by plugging in negative 20,000 newtons times 6 meters, because we're doing the distance from the end of the bridge to the car, times 1, and that's because cosine 90 equals 1, minus 500,000 newtons times 12, because the middle of it, the equilibrium, is going to be 12 because the total length is 24, times 1, plus F2, but we don't know F2, that's what we're solving for, times 24 meters, which the entire length of the bridge, times 1, and we all set that to 0. And when we solve it out, it's F2 equals 255,000 newtons. And we're going to do the same thing for F1. But we're going to do the total of them, which is actually going to be using this formula, which is F1 plus F2 plus negative FC, because it's still pointing down as negative, plus FG, because it's still going down as negative. And we set it all to 0. And we take F1 as the variable that we don't know, plus 255,000 newtons, what we got for the torque for F2, minus 220,000 newtons minus 500,000 newtons equals 0. And F1 is 265,000 newtons.